Welcome to today's ConSteel webinar. Today's topic is composite column design according to the EuroCode 4. My name is András Herbai. I'm going to hold this presentation. Just for some practical information about the user interface of GoToWebinar. Control panel can be hid with the red arrow button, and question or messages can be sent with the chat option, and at the end of the webinar I will answer them. Few words about the ConSteel 4 webinar series. Today's webinar is the first one in this series. Next webinar will be on the next week about the composite beam design, and the last one will be on the 19th of November about the plastic analysis hinge. Today's webinar content will be the following. At first I will shortly talk about the theoretical background of composite column design. Then I will shortly introduce the relevant parts of the EuroCode. Then I will show you the typical composite column cross sections, and finally I will demonstrate the design process in ConSteel 9. Short introduction for the composite column design. What is composite column? Steel concrete composite column is made from concrete and hot rolled or cold from steel section. EuroCode defines two main types, and the first one is the fully or partially encased I or H or Maltese section. You can see on the A, B and C picture. The second one is the concrete filled hollow or tubular section. If it is necessary, additional inner profile can be placed. You can see these types on the last three picture. Let's see the advantages and the disadvantages of the different composite column types. The first type is the concrete encased section. Advantages of this section is the high bearing resistance, the high fire resistance, and the economical solution based on the material cost. Disadvantages of this kind of cross-section type is the high cost formwork, difficult solution for connection with beams, and the difficulties in case of later strengthening of the column. Next cross-section type is the partially encased section. What are the advantages of this kind of cross-section types? High bearing resistance, especially in case of welded steel section. No formwork. Simple solution for joints and loading introduction, and easy solution for later strengthening and additional later joints. And what are the disadvantages? Lower fire resistance in comparison with concrete encased sections, the fully concrete encased sections. Let's see the last cross-section types. The concrete filled hollow section. What are the advantages of this kind of cross-sections? High resistance and slender columns. Extra high bearing resistance in case of additional inner profile. Constant cross-section for all stories is possible in high-rise buildings in case of additional inner profiles, and this kind of profile has advantages in case of biaxial bending. What are the disadvantages? High material cost for profiles, difficult casting, and additional reinforcement is needed for fire resistance, except additional inner profiles. Let's see the steps of the composite column verifications according to EuroCode. First step is to calculate the resistance of the member. EuroCode provides two different solutions. The first one is the general method. The second one is the simplified method. We will see the details on the next slide. The second step is to examine the local buckling. Outer steel plate parts can have local buckling failure. And the last step is to check the introduction of loads. Let's see the two different resistance calculation methods. The first one is the general method. This is a complex and complicated solution, but any type of cross-section and any combination of materials can be checked with this method. The second one is the simplified method. This is what ConSteel used to evaluate the composite columns. The simplified method can be used to evaluate the EuroCode recommended cross-section types, you can see. But the simplified method has some limitations. You can see the limitations. Only just double symmetric cross-sections can be used. Uniform cross-sections over the whole member length. The steel contribution is limited, and also the reinforcement ratio is limited, maximum the 6% of the concrete area, and the height-width ratio also limited. Here you can see the limitation of the cross-section. Okay, let's see how is it working in ConSteel 9. I have created 4 different composite columns previously, and if we switch the solid view, we can see on the graphic the different cross sections. We can see the inner profile, the reinforcement, and the concrete parts of the column. Let's see how we can define composite cross sections. Composite cross sections, as all of other cross section type in ConSteel, can be defined in the section administration. What can be found on the structural member tabs. Composite cross section can be found in the macro sections. In the composite part of these 3 structures, you can find the column and the beam. In the column section, we can find all of the EuroCode defined cross sections what were shown previously. It is important to notice that all of the steel profiles what we like to use in the composite cross section have to be loaded previously. Hot rolled and cold formed steel profiles also can be used. Let's see at first the fully encased high section in concrete type. With the next button we can open the dialog. Here we can see all of the parameters what we have to set. In the first field, the reinforcement parameters can be set. We can set the diameter of the reinforcement, we can set the material grade, and we can set the number of the bars around the cross section, the the upper bars, the lower bars, left bars, and the right bars. And also we can define the covers in millimeter. In the second field, we can set the dimension of the concrete section. We can set the height and the width of the concrete section, and we can set the material grade of the concrete. In the last field, we can select the steel profiles, the inner steel profiles from the drop-down menu. In the drop-down menu, we can see the previously loaded I or H hot-rolled or welded cross-sections. Now I'm loaded just 3 different. In the second part of the dialog, we can see some parameters for structure analysis. In the first field, we can select the modulus of elastic of the concrete, what we like to apply in the structure analysis. So we can select the second modulus of elasticity, or we can select the design value of elasticity. In the last section of the dialog, we can select 3 special settings. With the first check button, we can apply a special calculation of the effective flexural stiffness. We can take into consideration the shrinkage, the creep, and the cracking of the concrete section. And in the last 2 checkbox, we can apply initial sway in the Y and in the Z direction. The initial sway is defined in the EuroCode. So this is the EuroCode defined initial sway in the 2 different directions for this kind of cross section. According to the EuroCode, if you use this specified initial sway on the composite column and calculate second order analysis, then cross section check is enough. Stability check can be neglected. Okay, let's see the partially encased eye section in concrete type. We can find the same parameters what was shown previously, but yes, we can set the reinforcement, the steel section, and the concrete parameters, the concrete material grade, and in the second part we can set the special structure analysis parameters. Let's see the fully encased eye section in hollow section. In case of this kind of cross section, we can find some additional settings. We can select the outer hollow section. Now I'm load just 1 welded macro hollow section, and we can select, if it's necessary, the additional inner eye section. And the second part of the dialog is same. Okay. If the composite cross-section are created, then the composite columns can be placed in the modeling area in the usual way. We have to choose one of the member creator tool, for example the column, and from the first drop-down menu we can select one of the previously created composite cross-section. If we select one of the composite cross-section and we applied the initial imperfection on the cross-section dialog, the initial bow imperfection fields are automatically loaded according to the loaded cross-section type. Okay, let's see the previously created cross-sections. And if we select or switch to the line view, we can see on the model the applied imperfections on the member. I have applied some loads on the top of the column to run statical analysis, and the columns are fixed on the bottom. Let's go to the Analysis tab and run first and second order analysis, statical analysis. Okay, the analysis results are performed. Because the initial imperfections were applied for these columns, that's why the columns are rotated. We can switch between the analysis, and we can see also the internal forces. Okay, let's go further to the design check. Composite column check can be found on the global check tabs. If you click on the blue arrow button, we can set the parameters of the design check. In this case, just composite column check is available on the bottom of the dialog, because if you don't have any other kind of structural members, just composite. With the calculation, yes, from the drop-down menu, the only parameters that we can set to the composite column design is just the model portion, but you can select from the drop-down menu. But in this case, I haven't got any other model portion, so now I can run the calculation just for the whole model. With the calculation button, the design check is performed. In the graphical area, we can see the dominant utilization. We can see if you're moving on the column, we can see the utilization in all of the cross section. Now we see the dominant calculation. If we like to see, for example, the poor or local buckling resistance or the interaction resistance, we can select from the drop-down menu, and we can see the poor resistance. We can see the results of the cross section of the composite check in the table results. We can see the load combination. Now we have just one. We can see the dominant examinations. This is the interaction resistance, and we can see the utilizations in the last column. Okay. If we click with the right mouse button on the cross section or the utilization cell in the table, we can open the cross section module, where we can see the detailed results of the calculations. Here we can see the cross section model of this this column. In the right bottom corner, we can see the inner forces, and the top of the corner, we can see the detailed results of the cross section of the composite column check. We can see the summary. This is what we can see previously on the graphical area. We can see the place of the current section, and we can see all of the standard examination what can be performed for this kind of cross section in this loading area. So we can see loading situation. So, for example, in this case, we can see the poor resistance of the cross section, the compression, the bending about the minor and major axis, and also the shear in the major and minor axis. And if you see, for example, the bending about the major axis, we can see the utilizations, we can see the applied part of the standards, and we can see all of the parameters what were used in this part of the standard. And we can see the interaction check. We have 3 different interaction check: compression plus bending about the major axis, compression plus bending about the minor axis, and the last one, what is the dominant, the compression plus bending about the major axis and plus bending about the minor axis. Here we can see the utilization, so it's now, for example, it's not adequate, but you can see the parameters and the applied parts of the standard. If we are here in the cross-section module, let's see what can we see in the cross-section module in case of composite sections. On the standard resistance, we can see the resistance surface. Here we can see the resistance surface of our cross sections. This point is our loading situations. It's our current loading situation in the dominant cross section. On the right part of the dialog, we can see the design values, and we can see the extremes of the resistance of this resistance surface, and we can see the resistance lines through the axis, and we can see the sections through the points, the loading points, the constant normal force, the constant bending moment about the y-axis, and the constant bending moment about the z-axis. On the property tab, we can see the section properties. Here we can see the calculated section properties, and on this properties tab, we can see the stresses. This is a elastic stress calculations, and with this 3 button, if it's necessary, we can switch off all of the materials. For example, now I'm switched off the steel and the reinforcement. Now we are seeing you can see the stress, the normal stress distribution, and just in the concrete part of the sections. Let's see, for example, the another stress distribution. So here you can see in the concrete part of the sections. So here you can see. Yes, for example, so this is elastic cross-section calculation. So that's why we can see positive and also minus value on this stress distribution. But you can see also in the inner steel part of the sections. And you can see also in the reinforcement. And if we can see the values in the table results. Okay, let's go back to the model. Let's see, for example, another cross section. So this is another part, other kind of cross section. If we see the performed examinations, we can see we have another extra examination. So this is the local buckling check. So in this, for example, in this case, in this kind of cross section, we have to check the local buckling of the outer hollow section. And also we can see the stress distribution for this section also. Okay. And if we are ready with the design, the last step is the documentations. The documentation, the reports can be found on the documentation tab. With the start documentation button, we can create a new report. Now I'm create previously a report about our previously created columns. So we can see here you can see the parts of the report. Here you can find the model of the structures, the parameters, geometry, the material grades, the loadings, the supports, etc. We can see the results of the analysis. Now I put in the report just the second order analysis results. And the last chapter of the report is the standard design. We can see the summary of the ultimate limit state design. We have 4 columns, so that's why we have 4 utilizations. We have 2 tables. In the first one, the members are ordered by the name, and in the last one, the members ordered by the utilizations. Okay, and we can see the documented detailed results. So this is our first section. We can see the name of the structural member, the dominant cross section from the start point. So because the dominant cross section is on the bottom of the column. We can see the dominant load combinations. We can see the internal forces, and we can see the section parameters. You can see the material grades, the used material grades. Here we can see the design code, the dominant utilization, the dominant case, the examinations. Dominant was the interaction resistance, and we can see all of the performed examinations. Here you can see the pull resistance and the interaction of bending on the normal force and the apply part of the standard. Let's see another one, for example, the tube section. In this case, we have an extra examination, the local buckling check. And this is the hollow section type, and this is the partial engaged I section type. Okay. But composite column can be checked, not also just a standalone member. It also can be checked as a part of a 3D mixed model. So, for example, I create just a small 3D model. The columns are partial encased I section. You can see. The slab is a composite beam slab. The composite will be the design of the composite beam will be shown in the next webinar. And if we see the analysis of this model, we can see the deformation also, and we can see the internal forces. And if you go further to the global check, we can see the global check of this model. You can see all of the parameters, and then all of the dominant examinations and utilizations in case of stream model also. Okay, for now I'm done with my presentation. I would like to thank you for your attention. I hope you enjoyed and learned in this presentation. And I would be happy to welcome you back at our next webinar. So thank you very much and goodbye.